Okay, we are back and we are talking about logic 3 and logic 4 today. So we are just sort of expanding on everything that we learned in logic 1 and logic 2. So in logic 1 and logic 2, we talked about the initial conditional statement and we talked about the converse. So remember how we had if P, then Q, and then we knew the converse was the flip of that. So if Q, then P. The inverse is going to be the negation of the conditional statement. So if not P, then not Q. And then contrapositive, so this is sort of the weird one. This is probably a word you haven't heard of before. The contrapositive is going to be the inverse of the converse. So see how the converse is Q then P? So the contrapositive is going to be not Q then not P. Go ahead and pause this and make sure you have all of this down. Okay, so let's take this into account. So conditional, converse, inverse, and then the contrapositive. So let's look at an example here. So if the Nationals won, and I'm still reveling in the Nationals World Series Championship 2019. Woo-woo. So if the Nationals won, then they scored more points than the other team. So go ahead and pause the video, and I just want you to translate this initial conditional statement. Go. Okay, we're back. So hopefully you got if the Nationals won, then they scored more points. And if you just did like W implies P, that's totally fine. It doesn't matter how you abbreviate it as long as it makes sense. So that's the initial conditional statement. Now I want you to do the three other statements. So pause the video and write the three other statements. All right, so hopefully you wrote down that the converse is if they scored more points, then they won. The inverse is if they didn't win, then they didn't score more points. And the contrapositive is going to be if they didn't score more points, then they didn't win. Now, let's delve into this. I want you to think about all of these situations. Now, remember, we know that this initial conditional statement has to be true. We are going to take this as truth. I want you to think about whether these other statements are also true. So the next one, this converse, if they scored more points, then they won. I think for the most part that would be true, and this would be fun to debate in class. You could think about other ways maybe that they could win. Now let's talk about the inverse. So if they didn't win, then they didn't score more points. Well, if you didn't win, what if you tied? So you didn't win, but you also didn't score more points. So maybe that one's true too. But again, we could debate this in class, and that's why these are so fun. And then let's look at the contrapositive here. So if they didn't score more points, then they didn't win. And that has to be true, right? Because that's sort of the definition of winning, right? You scored more points than the other team. So I know that if this initial conditional statement is true, I know that this contrapositive will always be true. So the two ones I circled will always be true. The converse and the inverse are ones that get a little tricky. So remember, if the converse is true, you have what's called a biconditional statement. And we talked about this quickly in logic 1 and logic 2. So an example of this would be if 5x equals 10, then I know x equals 2, because the converse of that is if x equals 2, then 5x equals 10. Another thing, remember I told you, is a lot of these biconditional statements are definitions, and we're going to be using a ton of definitions in class this year. So here's an example, a silly example. But if you're a meanie, then you are a mean or small-minded person. So we've got an if and a then. Let's flip them. So if you are a mean or a small-minded person, then you are a meanie. That's true. That's a definition. So the converse could be true, but the converse could also be false. And if that is the situation that we're dealing with, then we have what's called a converse error. So logic 4 is all about errors. So let's look at this one. I want you to pause the video and go ahead and write the initial conditional statement. And then I want you to write the converse, the inverse, and the contrapositive. Go! Okay, we're back. So let's translate this guy. So if it's the Bahamas, then it's warm. All right, the converse is if it's warm, then it's the Bahamas. The inverse is if it's not the Bahamas, then it's not warm. And the contrapositive is if it's not warm, then it's not the Bahamas. So what do you think here? I know this initial conditional statement is true, but do I have a converse error? So if it's warm, then it's the Bahamas. What do you think? This is absolutely false, right? So I could be in so many different places. And whenever you think about something that proves that this is wrong, that this is a converse error, we talk about a counter example. So a counter example is something that proves that there is a converse error. And now the inverse error, let's think about this. If it's not the Bahamas, then it's not warm. Well, that's also not true, right? There's definitely an inverse error as well, because if it's not the Bahamas and it's not warm, it could be another place, right? Just the way we talked about the converse error. So a counterexample to that could be Florida or Mexico or wherever. And now, what about a contrapositive error? So let's look at the contrapositive. If it's not warm, then it's not the Bahamas. If it's not warm, then it's not the Bahamas. Remember, your initial conditional statement has to be true. So if it's the Bahamas, then it's warm. If I know that's true, then I know if it's not warm, then there's no way it could be the Bahamas. We could be other places, but there's no way I could be in the Bahamas. So there's no such thing ever as a contrapositive error, because remember, both the initial conditional statement and the contrapositive are true. Sorry that I just crossed that out. But remember, the initial conditional statement and the contrapositive will always be true. All right, so let's look at this last example. I want you to pause the video, translate this into its initial conditional statement, and then all of the following statements. And I want you to conclude that if you know that Mrs. Bixler is married, then you can conclude that she or I am wearing a wedding ring. Go for it. Okay, we're back. So here we are outside of Dingletown Church on Stanwich Road. A wonderful day back in 2016. So I want to show you what I wrote down here. So I wrote wedding ring implies married. That's the initial conditional statement. So then I did the converse, the inverse, and the contrapositive. So hopefully you have something that looks similar. So if I know that I'm married here, so Mrs. Bixler is married. So I'm going to go back and look at all my statements and see how I have married here as my hypothesis. That's what I'm looking at. So married implies wedding ring. And that's what they're asking me here. If you know I'm married, do you know that I'm wearing a wedding ring? So if I'm married, thus I'm wearing a wedding ring. So what do you think? I would say that that's a converse error, because I could be married and not wearing my wedding ring. It could be a hot day, or I just don't want to wear it, or I lost it, right? So you can be married and not be wearing a wedding ring. Hopefully this all made sense. Go ahead and tackle Logic worksheets 3 and 4, and we will touch base later. Thanks.